Alright guys, quarantine day one. You guys are my first, this is my test. Okay, you guys are going to be first. We're going to keep it short. Algebra 2. Make sure you're at the right video. This is going to be for Monday, March 16th. Last week we talked about we talked about logarithms. What's a logarithm? How do we use it? What do we use it for? Today and really this whole week we're going to talk about the properties of logarithms and how do we use logarithms to solve logarithmic equations. Okay. Again, like I said, I'm only going to do this first page today. We're going to keep it short. I'm just going to make sure all this stuff works. Right, properties of logarithms. There's 4 properties we're going to be using. These are, right at the beginning we got for all positive numbers m, n, and b, where b doesn't equal 1. B is going to be our base of the logarithms. And it says positive numbers because remember last week we talked about how logarithms can't be negative. If you enter a log of negative something, you're going to end up with an error in the calculator. Okay. All right, so we'll just run through these 4 properties and then that's it. First property is called the equality property. We're going to use this a lot in whenever the next lesson is. Basically, it states that if you have log base b of 1 equal to log base b of x sub 1 equals log base b of x sub 2, if and only if x1 equals x2. Okay, this is very similar to that when we were doing exponent properties. Exponent properties, if we had the same base, we only cared about their exponents. Same thing here. If you have the same log base, we don't care about the log base anymore. We only care about the numbers inside. So basically, if the bases match on both sides of the equal sign, then set the arguments equal to each other. The arguments being the inputs. All right, so in this example, okay, you always want to make sure your log bases are equal. We got log base 8, and we got log base 8 over here. Okay, so once your bases are the same, you only look at what's the input is. So we're looking at the 4x plus 10, and we're looking at the x plus 1. Okay, again, once you have one log on the left, one log on the right, and they're the same base, you can basically ignore them. Okay. So all we're going to do is we're going to set left side argument, 4x plus 10, equal to right side argument, x plus 1, and then solve this equation. Okay. Easy equation to solve. We get all the x's on the left. We get all the constants on the right. And we're left with, looks like 3x. That goes away, that goes away. 3x equals negative 9. Solve for x. Bring this over here. Obviously, divide both sides by 3. Negative 9 divided by 3 is negative 3. So x equals negative 3. Okay. Now one thing you have to check for is that this actually isn't an answer. Okay. It's an answer to the equation. We didn't do anything wrong. We solved that equation fine. But remember, we're not allowed to take the log of a negative. So if you get a value, you always have to check your answer. If we got a value for this, we got negative 3. Okay. Now negative 3 solves the equation that we set up, but it doesn't work in the answer. Okay. Because if you plug in negative 3 for x, you get, negative 3 plus 1 is negative 2. And over here you should get negative 2 again, negative 3. Plug in for that, you get negative 2. So you get log base 8 of negative 2 equals log base 8 of negative 2, which is true, but it doesn't work because we're not allowed to have negative logs. Okay. So this one, we're actually not going to circle that because that's what's called an extraneous solution. Okay. Extraneous solutions, we've dealt with this a couple times. We didn't do anything wrong. We solved it mathematically. We didn't break any math rules, but the answer doesn't work in the problem that was set up. Okay, so you always want to check that for logs. Okay. But that's how you'd use the equality property. The second property is called the product property. Now again, all these properties kind of go hand in hand with their exponent properties. The exponent product property is very similar to the logarithm product property. This property states that if you have log base b of m times n, you could separate that to log base b of m plus log base b of n. Okay. So we're going to use these properties going both ways. We're going to use them going forward, and we're going to use them going backwards. If you have two things being multiplied together, you could separate them with addition. If you have two logs being added together, you could combine them with multiplication. Okay, and again, that goes hand in hand with the exponent property. So let's look at this example. We got log base 3 of 14 plus log base 3 of x equals log base 3 of 42. Okay. Now again, for all these problems, the bases are always going to be the same. If they're not the same, we really can't do anything with it. Okay. So we got two log base 3's being added together. The product property states that we could take both the inputs and multiply them together. Okay. So I'm going to take the 14 and the x, and we're going to multiply those together. Okay. So we're going to write it as 1 log base 3 of 14 times x. And that's going to equal the right side. There's nothing we could do there. Log base 3 of 42. Now again, using the property from above, the equality property, we know that if we have a log 3 on the left and we have a log 3 on the right, we could just get rid of them. Again, we're not really getting rid of them, but we're going to ignore them for the time being. Okay. So really, we're left with this equation, 14x equals 42. Okay. And just pure instinct should tell you we should probably solve for x. Divide both sides by 14. And we end up with 42 divided by 14, so x equals 3. Okay. Now that one does work. It's a positive number. You plug it in, you get a positive. There's not going to be any errors in that one. So x equals 3. Third property, quotient property. Again, similar to its exponent counterpart. It states that if you have log base b of m over n, you could separate it as log base b of m minus log base b of n. Okay. So you got the division going with the subtraction. All right, in our example, we have log base 8 of 48 minus log base 8 of x equals log base 8 of 4. Okay. So again, our bases are the same, and we're subtracting. So subtracting, we want to think division. So we're going to write this as 1 log base of 8 of 48 divided by x. Okay. Equals the right side, which, nothing we could do there. Log base 8 of 4. Again, once these logs are the same and there's only one on the left and one on the right, we're going to ignore them. And then we're just left with the equation 48 over x equals 4. Now remember, if you have a variable in the denominator, you could just switch their positions. Okay. Now again, mathematically, what we're really doing is we're multiplying both sides by x and then dividing by 4. But in the setup, that's always going to work. We could just switch them. Okay. So we're left with x equals 48 over 4. So x equals 12. 48 divided by 4 is 12. Again, that answer doesn't make anything negative, so it's good. All right, and the last property, the power property. Power properties, this one's really important. We dealt with this a little bit when we were doing some of the other log properties. It basically states that if you have log base b of m raised to the p power, you could take that exponent and put it in front of the log. Make it p times log base b of m. Okay. Now again, we're going to use this going forward and backwards a little bit. In this problem, we have 4 times log base 8 of x equals log base 8 of 81. Okay. So using this property, we're going to rewrite this, and we're going to take the 4 that's out front, and we're going to make it the exponent. Okay. So really, we're going to have log base 8 of x to the 4th power equaling the right side log 8 of 81. Just like all the others, once you have one log on the left, one log on the right, we're going to ignore that part and just worry about the arguments. So really this is x to the 4th power equals 81. And you can take the 4th root or raise it to the 1/4 power, or just kind of figure out some number sense. 2 to the 4th power is 16. So you try the next one. 3 to the 4th power is 81. 3 times 3 times 3. Okay. Again, -3 also works. So -3 times -3 times -3 times -3 is 81. But again, it's going to make one of our arguments negative. So this one's only the positive version, x equals 3. All right. And those are the 4 properties. We're going to be dealing with these all week. Power property. If you got an exponent, you can move to the front. If you have something in front, you can move to the exponent. Quotient property. If you're subtracting 2 logs, you could write it as 1 through division. Product property. If you're adding 2 logs, you could write it as 1 log using multiplication. And then the important one, the quality property, they're all important. The quality property, if you have the same base, there's 1 log on the left, 1 log on the right, same base, you could just, then their arguments have to be equal to each other. So you could set their inputs equal and solve. All right, that's it for the first, and always check for extraneous solutions. Again, you can't have negatives. You can't take the log of a negative. All right, quarantine day 1. We've been trying to keep it short. Hopefully that was short. I'm not sure. We'll do the rest of this tomorrow, and I'll have a worksheet tomorrow as well. All right.